Welcome to the pHindicator Experiment Show. That's the pH Indicator Experiment Show with your host, Augustine Gold. But you can call me AG for short, just like my two favorite things, silver and gold. Today we're going to be using red cabbage as an indicator for several acids and bases. Red cabbage contains pigments called anthocyanins. The pigments give the red cabbage its reddish color. Anthocyanins belong to a group of chemical compounds called flavonoids. This experiment will show you how you can make your own pH indicator using the cabbage leaves. Before we begin, I'm going to explain a few things about pH, acids, and bases. An acidic solution contains an excess of protons or hydrogen ions. pH is a measure of how acidic a solution is. The lower the pH, the more acidic the solution, the more hydrogen ions it contains. In mathematical terms, pH is equal to the negative log of the concentration of protons in the solution. For most pH indicators, the compound acquires a proton at a low pH, but loses it at a higher pH. This small alteration is sufficient enough to alter the wavelength of light reflected by the compound, which creates the color change with respect to the pH. This is where we will see the color changes from deep purple of the red cabbage to red, orange, and yellow for acidic solutions and blue and green for basic solutions. The intensity of the color will dictate the intensity of the pH. Anthocyanins behave somewhat inversely in that the pigments gain an OH group at basic pH and lose it at acidic pH. To begin the experiment, you must first gather all your supplies. We have a head of red cabbage, a nice sharp knife, some household acids that we found, and some bases. So first what we're going to do is we are going to cut the cabbage. This is actually already pre-sliced to show you some of the color that's inside. And so what you want to do, not drop the cabbage on the floor, is you're going to cut it up nice and thin. But make sure that you have a blender handy because you're going to put it in the blender. Right now we also have a pot of boiling water on the stove. You don't really need to measure it, you can just put a whole bunch in there. So I'm just going to chop this cabbage all nice and neat, put it in the blender for you. My assistant will be over in just a minute to grab it. So it doesn't have to be any neat order, you can just cut it sort of like you're cutting an onion. Be careful not to cut yourself. So my assistant Lindsay will take it to be blended.
I'm adding the hot water that draws out the pigment. Now blend it.
Make sure put the rounded part over the edge or else it'll blow out. As we know from an earlier demonstration.
Which one do I mix or?
It doesn't matter. That's good.
Alright, now that I made a mess, we'll bring it back to drain out the juice.
So after you're done blending the cabbage in the hot water, what you're going to want to do is using a filter, pour it out because all you're going to want is the juice, not any of the leftover cabbage that's in there. It's recommended for a two-person job unless you're an expert blending pourer. But we're going to try this out so we don't make such a big mess here. So Lindsay's just going to pour it in little by little, and then we're going to use what's left over in the cup. So now we have our juice all eradicated from the extra cabbage stuff. Not sure what the scientific word for that is, but so now we're going to pour it in our different beakers, sort of, that we have. We're actually using pint glasses from some of our favorite places. And so I'm just going to go in here and suck some up, and careful not to spill it everywhere. And don't forget, wear your goggles. Safety first, especially when pouring liquids. Just fill it up a good amount. We'll see what we have left over so we can get some good colors. Throw it over here. Little Debbie. There's a good treat. But don't eat it in the lab. Save that over here for later. So I'm going to add a little catalyst here to speed the reaction up. I'm going to fill up another glass for a mystery component that we have. So here we have water. And we're going to add a little bit. Just to show you, this is our control. And we'll start with the bases first. We have our old antacid, for those of you that love to eat some acidic food and get heartburn from time to time. Pop one of these and it dilutes some of the stomach acid. So we're going to put 3 of them in here. Stir it up a little bit, see what we get. I think you'll see a good change in a few minutes after we just let them sit for a little while. So let's just get them all set up here, and then we'll wait a few minutes and see what kind of colors we get. So we also have some sodium bicarbonate, aka baking soda. And this was calcium carbonate, so they're pretty similar. You can already see this reacting, a nice teal color. Let's add a good amount. Let's saturate that solution right up. And then here we have your household Windex or glass cleaner with ammonia. And this is already blue, so we'll have to see what kind of indication it'll give. But these are all bases that we know, so they should give some darker blues or green colors. And then we have some sodium carbonate, which is your standard dish detergent. Got a nice green color there. Let's mix that up a little bit. Move over to the acids. We have some vinegar. Pretty acidic solution. I think it's around like 3 or 4. See what I mean about the goggles? So that's a nice pink color there. Then we have some lemon juice. Nice on your fish. It's also a pretty acidic solution, nice pink color. Here we have some toilet bowl cleaner, which is also a blue color. It's actually almost a darker color than this, and you'll see that in a few minutes turn a nice fuchsia color almost, I guess we'll call it. And then finally we have the chili sauce. So we're going to pour this right in and see. I think it's going to be acidic. And then our mystery container, we have some dog shampoo because we all love dogs and we just want to see what we are putting on their skin, and that's one of the #1 ingredients is sodium sulfate. So we'll just let these sit for a few minutes and we'll be right back. Welcome back! During the break we arranged our products from the lowest pH here, which is the most acidic containing the most hydrogen ions, to the highest pH over here, which is the most basic and least acidic containing the least amount of hydrogen ions. You can see that the colors vary from product to product. We have a really light pink here, and it goes on to a darker pink as you approach the middle. Water's neutral and it stays sort of at the color that the red cabbage formed. We have the antacids and then the cleaner, and you can see this nice green milky stuff is what you wash your dishes with. Thanks for watching. This is AG Gold. Tune in next time for Predicting the Future with KSP calculations. We'd like to give a special thanks to the chemistry students of class Chem 115 at the University of Southern Maine. We have Lindsay Fox, who's my assistant and blender operator, and we have Kyla Clark, who is a filmographer and director. So we'll see you next time.
Mazel tov!